Okay, so now that we have a pretty good view on all the all the aspects of polymer chemistry, polymer engineering, and their properties, let's touch on the manufacturing options and what that might mean for the ultimate properties of the material. So we've looked a lot at polymerization, the polymer chemistry, molecular weight details, and we've seen here some details on how the molecule is configured or structured can affect if crystallinity is present, and clearly that affects things like the density, the mechanical properties, degradation resistance, things like that. These other thermal properties like the glass transition temperature or melting of the crystals, the lamellae that we know about now, those are also related to molecular weight. And ultimately the selection of either a thermoplastic or thermoset is linked to the polymer chemistry and molecular structure. So ultimately, those polymers put through some sort of processing approach can also tune the ultimate properties in a sense. So the processing structure property relationships are all tied together to the ultimate performance of the material once it's applied into its service use, like a composite or a textile material. Okay, so what are the common manufacturing approaches? So there is injection molding or even reactive injection molding if you have to handle thermosets. There's extrusion, where molten material comes out of a die. We'll see that. You can flow the material and expand it with gas to do blow film forming processes. Compression molding, asking the molten thermoset or thermoplastic most commonly to occupy the cavity of a mold and ultimately allow for shaping of the material. Blow molding is related to the blow film forming approach. Even thermoforming and casting are known as well. So let's touch on some of these with the remaining time we have together. So injection molding, how does this work? It starts over here, and it involves a hydraulic pressurized ram that can retract and allow polymer pellets. So these might be the size of the eraser on the back of your pencil. These polymer pellets would fall from a hopper, which feeds into the cavity where the ram would otherwise exist. And they would drop into the barrel. The ram would then allow the plastic to get forced into a heating chamber that we see here, heating chamber, where a spreader can help make sure that the plastic, as it transitions into its melt state, can move throughout the cavity and mix uniformly and relieve any cavities and ultimately create a nice fluid material. And ultimately, this hydraulic pressure and ram helps drive the molten plastic from that spreader heating chamber area into a mold where the kind of cavity not occupied by mold material will ultimately acquire the molten plastic. So the molten plastic is forced under pressure into the mold cavities where it takes the form of the tool or the mold cavity there to make the final object. Okay, an extension of that approach is the extrusion approach. So here again, a hopper is used, and those same pellets that might be about the size of the eraser on the back of your pencil are drawn into a cavity. Here a turning screw is used, and heaters may be installed along the barrel of that extruder to allow heating. The screw would also provide pressure, so the combination of heating and pressure here transitions the polymer from its solid pellet state into its molten form, clearly going above glass transition temperatures and melt temperatures, and drives the material forward. And ultimately, at the end of this screw and its barrel is a shaping die. So the orifice there, the opening of this die, dictates how the extrudate, the material coming out, what shape it takes. So if you imagine that die looking straight onto it had a opening that looked like one of these sort of V structures, where all this is metal, and shown in white is the pathway into the barrel where obviously molten plastic extrudes from, you would get a feature and an ultimate extension of material coming out of that die in the form of this sort of V-shaped structure. Okay, extrusion to create blown films, very similar structure there. So we have the same upstream components that we saw in the extruder, except the extrudate is this time directed upwards via a tubing die, and that includes a pathway for air or gas in to provide ultimately an air cavity as the extrudate expands away from the pressure of that air and creates a bubble of that extrudate of the thermoplastic. And ultimately that thermoplastic material is allowed to cool as it travels up to some guide rollers and pinch rollers for kind of recovering the material either in the form of a film, or there can be some cutting to provide freestanding sheets, or ultimately even perforated bags, for example. Okay, and another approach might be the compression molding approach. So here, this is common for both thermoplastics and thermosets. It's kind of a one-at-a-time serial approach, so it lends nicely to thermosets, whereas more dynamic materials that don't permanently set, like thermosets, typically can't be used in the former approaches unless very careful conditions are known. But in this case, both thermosets and thermoplastics can be used, so the polymers and any additives are placed in a mold cavity that is, of course, starts open. The mold cavity can be heated, and then ultimately top plate can be dropped by hydraulic pressure or other means, and the top kind of mold plunger, for example, might help set the final object shape. And that mold cavity might receive some of that mold plunger, and any volume between that top mold plate and the bottom mold plate would create the ultimate volume and shape of the samples. So here, the combination of heating and pressure allows the polymer to become and access its fluid shape and assume the shape of the mold, where the top plate and the bottom plate are carefully machined to set that shape. Okay, and so with that, I think we'll end, and that brings us to a good point to return back to other work on mechanical properties for the rest of the and mixed materials and ultimately composites for the rest of the course. Great.